Good evening, all. In this session, we are going to see about the classification of network elements. Network elements have been classified likewise. First one, based on the property of the elements, they have been classified into active or passive elements, unilateral and bilateral elements, lumped and distributed elements. Based on the response of the elements, they have been classified into two types, linear and nonlinear elements, time invariant and time variant elements. So first we will go based on the property of the elements. So active elements and passive elements. Active elements are the elements which have the capability or ability to generate the energy by themselves, called active elements. Example like batteries, generators, transistors, etc. Passive elements are the elements which do not have the ability to generate the energy by themselves. So maximum they depend on active elements. Example for the passive elements like resistor, inductor, capacitor. So some of the active components and passive components examples has been given here. And now we go for unilateral element and bilateral element. Unilateral element, the conduction of electric current, if it is in single direction, then those elements we call it as a unilateral elements. So examples you could able to see like vacuum diode, rectifiers, transistors. A bilateral elements means if the conduction of the current is in the both directions, is called bilateral elements. Example, resistance, inductance, and capacitance. Some other elements we see lumped elements and distributed elements. Lumped elements. Elements which are physically separable. They are said to be as a lumped elements. Example, resistor, inductor, capacitor. Distributed elements. Example, so elements which are not physically separable. Elements which are not physically separable are called distributed elements. So example, transmission line. And another classification of the elements we could able to see linear elements. Elements which obeys Ohm's law are called linear elements, are the elements which are having a proportional relationship between the voltage and current. You could able to see here, if some sort of potential has been provided, then the established current in that conductor, if they have proportional relationship, if one is getting increased, other one is also getting increased about, like a ramp signal. Those elements we call as a linear elements, whose characteristics, VI characteristics are in a linear line or a straight line. So example for the linear elements are resistor, inductor, capacitor. You could able to see here the VI characteristics. A non-linear element are the elements which doesn't obey Ohm's law, or whose VI characteristics are not in linear or straight line. Those elements we call it as a non-linear. elements. Like you see here, the characteristics, VI characteristics are not in linear, like a ramp signal. They are in somewhat irregular shape. So example for the non-linear elements, you could able to see diode here. Then time variant elements, if output characteristic changes with time, if they are varying with time, those elements we call it as a non-linear, time variant elements. And if the output characteristics are doesn't change with respect to the time, if they are not changing with respect to the time, those elements we call as a time invariant elements. So in the case of RLC components, they are like a passive, bilateral, lumped, and linear elements. So electrical energy sources we have here. Basically, sources have been classified into two types only: independent sources and dependent sources. Again, independent sources have been classified into two types: ideal sources, practical sources. Further, ideal sources and practical sources, they both are further classified into four types, like ideal voltage source, ideal current source, practical voltage source, practical current source. So here you could able to see ideal voltage source, practical voltage source. In the case of ideal voltage source, the internal resistance is assumed to be 0. Due to that, the VI characteristics of the voltage is maintained constant here in the case of ideal voltage source. In the case of practical voltage source, here in series, a practical resistance parameter is to be considered about. Due to this presence of the series resistance, the drop is going to be added and the net voltage across the terminals is going to be reduced about due to the calculation or due to the appearance of the series resistance and its drop. Net voltage across the terminals is going to be decaying about. Then ideal current source, practical current source. You could able to see here ideal current source. Ideal current source, we will assume that in the ideal current source, the internal resistance is infinite. The current characteristic seems to be constant. Ideally means they are constant only. In the case of practical, a shunt resistance is appeared here. That due to this presence of this shunt resistance, so current deviation is also taken into the consideration through this shunt resistance. Then the net current across the terminals AB is going to be decaying about, decreasing about due to the shunt resistance and current flowing through the shunt resistance. The net current across the terminals is going to be decaying about. You could able to see here. And dependent sources, they have been classified into four types. First one, voltage dependent voltage source, or we can also call it as a voltage controlled voltage source. Then current controlled voltage source, or we can also call it as a current dependent voltage source. Then third one, voltage dependent current source or voltage controlled current source. Fourth one, current dependent current source or current controlled current source. Now you see here, dependent source, voltage controlled voltage source or voltage dependent voltage source. So all the dependent sources are being represented with a diamond shape. So inside the terminals are being provided. Rhombus or the diamond shape means the dependent source. So if plus minus provided means voltage source, arrow indication provided means current source. Now you see here, rhombus shape, dependent, plus minus voltage source, dependent voltage source, depending on some 5 volts. So depending on some extra additional 5 volts, this is the example for the voltage dependent voltage source. Now here also you see here, rhombus or diamond, dependent plus minus voltage source, depending on current. So current dependent voltage source or current controlled voltage source. So here rhombus or the dependent diamond shape means the dependent source, arrow indication is current source. So dependent current source depending on some extra additional voltage parameter V, 5V. So voltage dependent current source or voltage controlled current source. Here also you could able to see rhombus or the diamond shape dependent, arrow indication is a current source, dependent current source, depending on some additional 5 volt parameter, 5 current parameter, depending on some additional 5 volt, 5I. So current dependent current source or current controlled current source. So in this, all the dependent sources are being represented with a diamond or rhombus shape. Inside the sign is being replicated, whether if it is plus minus voltage source, arrow means current source. All the independent sources, all the independent sources are being represented with a circle. All the independent sources are represented with a circle. See here, whether it is voltage source or current source, inside the sign is being represented. If it is plus minus, independent, circle means independent source, plus minus independent voltage source. Similarly, circle means independent source, arrow indication current source. Next topic we will see in the next session. Thank you.